Okay, we've been talking about finding derivatives, and we just started with that concept yesterday. And I just want to continue on with a little discussion on derivatives. Remember that the definition of a derivative is just the slope of a curve at a point. And we're going to take that idea and we're going to continue on. We're going to do a couple more problems finding the derivative of some sort of function. So the first one we're going to do is we're going to find the derivative. Remember, we label that f prime of x of our function f of x. In this case, it's 2x cubed minus x. So before we go through finding our derivative, let's first figure out what our f of x is and our f of x plus h is, right? Because those are two things that we need. Our f of x, obviously, that was given to us, that's 2x cubed minus x. Our f of x plus h is going to be 2 times x plus h cubed minus x plus h. And we need those because, remember, by definition, right, we just said that the derivative is the slope of a curve at a point. And so we need to figure out what that slope is, so we have to use our formula. So we have to take the limit of f of x plus h minus f of x, all of that over h. So I have my f of x over here. I also have my f of x plus h. Now, here's something that you should be familiar with, and if you're not, I would probably go back and look it over. If you're not sure, I can go over it with you at any point. But when you are cubing a binomial, I'm just going to write this over here. When you cube a binomial, you can use Pascal's triangle to get the coefficients. Basically, what it comes out to be is this: x cubed plus 3x squared h plus 3x h squared plus h cubed. And that is what it will always be. It won't ever change from that. So if you're not familiar with that, make sure that you get familiar with it. The only thing that would change is if there's a negative sign in there, and that changes some of your signs. Okay, but otherwise, those are the coefficients that go with that. So in our case here, we have the limit. I'm going to erase this line. We have the limit as h goes to 0 of 2 times all of this. So I'm going to combine this all into one step. So I have 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed. So that's this first part minus x minus h. Okay, so that takes care of the f of x plus h, and now I have to do minus f of x. So minus f of x would be minus 2x cubed minus x in parentheses. So if I distribute that negative, I get minus 2x cubed plus x. Okay, I was just trying to combine a couple of steps into one. Those are just the basic rules of algebra that I applied right there. So now I have the limit as h goes to 0 of what? Well, let's see what I can cancel. I can get rid of my 2x cubed. I can get rid of my negative x. I can get rid of the positive x. And so what I'm left with then is what? I have 6x squared h plus 6xh squared plus 2h cubed minus h. All of that over h. Now I can factor an h out of all of my terms in my numerator. I'm left with 6x squared plus 6xh plus 2h squared minus 1. All of that over h. My h's cancel, so I'm left with the limit as h goes to 0 of 6x squared plus 6xh plus 2h squared minus 1. Now, as h goes to 0, this term will go to 0 and this term will go to 0. So what I'm left with is 6x squared minus 1. Okay? And that is my derivative. That is my formula for the slope. And so now, if I wanted to, I could find the equation of a tangent line to that point. Or, excuse me, to that function at a point. Okay, so our derivative was, right, f prime of x, our derivative was 6x squared minus 1. And so let's say I want to find the equation. Find equation of the tangent line at x equals 3. Remember, my original function was 2x cubed minus x, right? That was my original function. I want to find the equation of the tangent line at x equals 3. Well, if I plug 3 in here, right, so if I find f of 3, that gives me 51. So now I have my point. My point is 3, 51. I have a point, right? I can also find my slope because the derivative represents the slope, right? I can find my slope. I can find f prime of 3. So at x is 3, what is the slope of that line? If I just plug in 3 into my derivative, I end up with 53. And so then if I use my equation for slope of a line, right, point slope form, I have a point and I have the slope. So I would give me y minus 51 is equal to 53 times x minus 3. Okay? And you guys can figure out the rest from there and what you would have to do from there. That's the idea behind the derivative for that. Okay? A couple of other things I want to talk about are the ideas of differentiability. And when we talk about differentiability, what does that mean? Let me explain that. Differentiability. Differentiability. In order for a derivative to exist at a point, the limit has to exist at that point as well. Okay? So, in order for a derivative to exist at a point, the limit as h goes to 0 of f of x plus h minus f of x over h must exist. Must exist. Can't take the derivative of something if you don't have a slope there. Okay? So, here are two different implications of that. Here's the idea. If you have a function, right, that has a sharp point. If you have a function that has a sharp point, okay, this is a continuous function, right? I can draw this function without ever having to lift up my pen off the paper. But the limit of the slope doesn't exist, right? Or the limit for the slope doesn't exist because the limit of this doesn't exist. Does that make sense? Think about it. Remember, in order for a limit to exist, the limit must be the same from the left and from the right. Okay, and in this case, it's not. So the limit of the function exists at this point. The limit of the function, because my limit as I approach from the right and left is going to be the same. But the limit for the slope doesn't exist. So let me explain what I mean. Let me write that out first. The limit for the slope doesn't exist. Okay, the limit for the slope doesn't exist because it's not the same from the left, I'm just going to abbreviate here, and the right, which means you cannot take the derivative. So what I mean by that is this. As you're approaching this point here from the left, look at my slope. My slope is positive, positive, positive. But if I'm approaching from the left, my slope is, from the right, my slope is negative, negative, negative. My slopes as I'm approaching from the left and the right are not the same. And because my slopes aren't the same from the left and the right, I can't take the derivative because the derivative refers to the limit. Okay? So, when you have a sharp point, you cannot take the derivative at that point, even though the function is continuous. The derivative does not exist. Okay, so even though the limit of the function exists, the derivative doesn't necessarily exist. Let me give you one more example of that. If you have a function, whoops, here's my axes. If you have a function that's almost vertical, not exactly vertical, but almost vertical, it also doesn't exist, okay? It doesn't exist because you cannot take the derivative where the slope is undefined. Cannot take derivative where the slope is undefined. Okay, if you look here as you go this way on your graph, right, your slope, is getting more and more, it's going towards negative infinity. Here your slope is going towards positive infinity, meaning as I'm traveling this way, my slope is going towards positive infinity, but if I'm coming this way, right, my slope is getting more and more negative. Okay? So, two situations where you cannot take the derivative at a sharp point or where the slope is undefined. The slope of the function is undefined. You cannot take the derivative. That's about it for now, and we'll see you next time. Take care. Bye-bye.